Okay, so we'll go through these problems rather quickly. Hopefully they'll make some sense. So the first thing to answer, as x gets close to 1, what is my function getting close to? Well, we see as x is getting close to 1 from either side, the y value that it's close to is -2. So that's 1 is false. Part 2 is saying what this should jump out at you is this is the slope equation. So this is really just saying what is f prime at 2? And so we can calculate that f prime at 2. It's this linear equation, easy to calculate. It's just a slope of 2, so that's true. And then the second question says, as x approaches -1 from the, I think that's from the positive side. Yeah, from the positive side. So as it gets close to -1 from the positive side, so imagine us getting closer to -1 from the positive side, we are approaching 1. And does that, in fact, equal f of -3? Well, f of -3 is here, and that also is 1. So this is true as well. So our answer is D. Okay, for the next question, I did a little bit of work already. It's looking for when the instantaneous rate of change of f is greater than the instantaneous rate of change of g. Well, the instantaneous rate of change of f is just its derivative. Using the chain rule, we get 2 sine of x cos of x. And for g, just the power rule, g prime is 2 comes down, makes that just x. And for f prime is going to be greater than g prime as long as f prime minus g prime is greater than 0. So what I did is I went into my calculator and I entered in f prime minus g prime, and then I went into my window and I just plugged in these values here into my input, and I got out that the only one that's positive is 0.9. So that makes C the answer. If you're not sure how to do all of this calculator work, make sure you get some help. Ask me about that or ask a friend, because you should be pretty adept with your calculator. Okay, another calculator question. We're looking for, we've got some function f of x, another function g of x, and we want to know when the following statement is true. Well, I could rewrite that as the integral from a to b of f dx minus the integral from a to b of g dx must be greater than 0, just subtracting this over to the other side. And then I could rewrite that again. I could combine these as the integral from a to b of f minus g dx. And I'm looking for when that's greater than 0. So what I did is I just plugged f minus g into my y1, and then I used the second calc integrate button from, integrating from -1 to 0, from 0 to 2, and then from 2 to 3. And if we look at what the integrals equal, the only time it's greater than 0 is for this case, so that would be 2 only. Answer B. All right, second derivative. So we've got an implicit equation. If I take the derivative of both sides, what I get on the left-hand side is 2y times dy dx minus 3 equals 0. Solving that, we get dy dx equals 3 over 2y. And if I take that one step farther, so now I'm going to take the derivative with respect to x of both sides. I get d squared y dx squared equals, well, using L'Hopital's rule, or not L'Hopital's, using the quotient rule, I have low d high minus high d low, which is 2 dy dx, all over low squared. Well, when I square low, we get 4y squared. Okay, well, we can see that this is 0. We can replace, for dy dx, dy dx was just this. So that can go in here. And then we've got this y squared to deal with. Well, going back to my original equation, going back to that original equation, we have that y squared equals 7 minus 3x. Okay, so this is going to work out nicely. So this can be replaced with negative 6 times dy dx, where dy dx is 3 over 2y, all over 4 times y squared, where y squared is 7 minus, oh, well, it looks like our answer is just in terms of y squared. All of these answers are in terms of y squared. So let's just keep the y squared there. It's 4 over y squared. Okay, well, if we do a little bit more simplifying here, let's see, we can divide by 2 and we get 3, 2, and do some multiplying. Negative 3 times 3, we get negative 9 over 2y divided by 2y squared. And then we know that this is just negative 9 over 2y times 2y squared. That's just working with fractions. And this equals negative 9 over 4y cubed. And hopefully that's one of our answers. Let's go up and see if it is. Negative 9 over 4y cubed. Answer E. Great. Okay, number 5. We've got two functions, f and g, and we've got a function h of x, which is g of f of x. It says, which of the following statements are true about the function h? So h of 0, let's see, h of 0 it is equivalent to g of f of 0, and f of 0 is 5, so we can replace this with g of 5, and g of 5 is 0. So number 1, not true. All right, question, or part 2 says h is increasing at x equals 2. So if we're dealing with something being increasing, we're thinking about its derivative. So we need to find the derivative. So h prime of x equals g prime of f of x times f prime of x. And we're looking at 2, so this is g prime of f of 2 times f prime of 2. Well, if we look at f prime of 2, that tangent line has a negative slope, so we know that this value is going to be a negative. And f of 2, so now if we look over here, f of 2 is 1, so this value is the same thing as g prime of 1. So if we go over to g and look at its slope at 1, it's also negative. So a negative times a negative results in a positive number, which means that h must be increasing. And then the last question, we're going to use that slope equation again. It says the graph of h has a horizontal tangent at x equals 4. Horizontal tangent, we know, just means that g prime equals 0. So let's look at x equals 4. So we have the h prime of x equals g prime f of x times f prime of x. It's the chain rule written again. At 4, we have g prime of f of 4 times f prime of 4. Well, f of 4 is 2, and g prime, so this is just 2, and g prime of 2 is 0. So as long as this whole thing equals 0, then h prime of x equals 0. So that also is true. So we have 2 and 3 are correct, so D. Okay, I did a little bit of work already for this problem. We've got the curve y equals e to the x. So if we just choose some, and we're looking for the distance, minimum distance to the origin, and we actually don't even need to use calculus for this problem since we have our graphing calculators. So if we just choose some random point on this curve, every single point on this curve is the point x comma e to the x. And if you remember the distance, we're trying to find the distance to the point 0 comma 0. So the distance equation is just, the distance equation is the square root of point, our x value from point 1 minus our x value from point 2 squared plus our y value from point 1 minus our y value from point 2 squared. Think of this as just being, it's just Pythagorean theorem. So that's what I put into my y1 equation here. And then all I'm looking for is to find a minimum value. And that minimum value, since we're looking for the minimum distance, we're talking about the y value, which is right here. So that's 0.780. D is our answer. All right, so we're looking for, this is an area problem, so it's bounded by the y-axis, the line y equals 4 minus x, and the graph x minus cos x. So I put those two different y's into my graphing calculator. Here's the shape that I got right here, and then what we needed to, so it's bounded by the y-axis and these graphs. So we're talking about this area. Let's draw that area in red. And what I needed to do is I needed to find that intersection point. The intersection point is this point right in there. So I used my calculator to find that intersection point. So then what I want to do is I want to find the area. Well, to find the area, it's just the top minus bottom function. So it's 4 minus x minus x minus cos of x dx. And I'm integrating from x equals 0 to the intersection point that I found, which is 1.858. So here, I'm putting this into my graphing calculator, using the calculator to do the integration, because it saves time, no need to do it by hand, and we get 4.939. So answer E. Okay, changing concavity. A function changes concavity. The only places where it can change concavity is where the second derivative either equals 0 or it's undefined. So let's find the second derivative. We get the first derivative is 4x cubed minus 2x minus 2 e to the 2x, using the chain rule on that last term. And then y double prime is going to be 12x squared minus 2 minus 4 e to the 2x. Taking the derivative of the e to the 2x, we're going to keep bringing a 2 down, multiplying it by 2. Okay, well, this is my second derivative. Now, since we have calculators, I plugged this into y1, and I graphed it. Here's the graph, and I'm just seeing when does this equal 0. So I use the 0 function on my calculator, and it equals 0 there. So our answer is B. Okay, this is a fundamental theorem of calculus problem. We've got ice melting in a pond, sort of like what's happening on Squam right now, and it's given by, this got cut off, dv dt equals the square root of 1 plus 2 to the t. So what we know is that the integral from a to b of dv dt equals the change in volume. So what we do here is we're just integrating from 0 to 5 minutes our rate, which is 1 plus 2 to the t dt. So I entered that into my y1, and I used the calculator to do the integration, just from 0 to 5. We get an answer. The answer is here, and we feel confident. Number 10. All right, this is the hardest one to do on a video, and so if it's confusing, it might be worth coming to get some extra help. What we're doing is we're going to use the trapezoid rule to find the volume when this is rotated around the x-axis with 5 equal subdivisions. So if we think about the trapezoid rule means making trapezoids. So here would be our first trapezoid. and we're going to rotate that around the x-axis. So we're going to get something that looks like this. But as it rotates around the x-axis, what you're going to get is a disk, and it's going to have, here would be like my bigger radius, and then your smaller radius. And the depth, this sort of depth that gives it 3D-ness, this change in x, is always going to equal 1. And so what the trapezoid rule is saying that is what we should use is the average height between here and here as our radius. So it's going to take this disk and this trapezoidal disk and really turn it into just like a regular pancake, I guess. So, from 1 to 2, what we're going to have is, again, we're using area equals pi r squared times our delta x, where our delta x, again, is 1. So for the first one, we're going to have pi times r squared, where r it's the average r, so 2 plus 3 over 2 squared times 1, plus, so that's doing this. And then to find this one, we're going to have pi times 3 plus 4 over 2 squared times 1, plus, so now you sort of probably see what's going on, pi times 4 plus 3 over 2 squared times 1, plus pi times 3 plus 2 over 2 squared times 1, plus the very last one, pi times 2 plus 1 over 2 squared times 1. Now, this takes a little bit of calculator work to actually figure out all of this, but it's a reasonable thing to just dump into your calculator. Okay, sorry about that. A little bit of a brain fart, I guess. Okay, let me restart this. I was rushing and made a very simple mistake here. What we need to do here is think about adding the average, not of the heights, but the average of the areas. So if we look at this first one again, here it has a height of 3, here it has a height of 2. So if we think about using the left-hand side, it's, pi r squared, and then we're going to average that with the right-hand side, plus pi times 3 squared. And we're going to take the average of the areas over that range. Now again, that was like us taking, our outer pancake had a radius of 3, and our inner pancake had a radius of only 2. And this expression finds the average area of those two pancakes. And then we're going to multiply that by change in x. And again, where our change of x just equals 1. So if we do that all out, our first one is like we just wrote, and we can factor out the pi and factor out the 2. So we have pi over 2 squared plus 3 squared, plus, and then if we look at this one, it's also going to have pi over 2, and then it's going to be 3 squared plus 4 squared, plus our blue one, which is pi over 2, 4 squared plus 3 squared, plus our black one, pi over 2, 3 squared plus 2 squared, and then our last red one, pi over 2, 2 squared plus 1 squared. And similar to, the work we did when we were doing trapezoid rule with just, 2 dimensions. This simplifies to just pi times, um, all of our inside things get repeated. Everything gets repeated except for the first and the last value. So this ends up being pi over 2 squared over 2 plus 3 squared plus 4 squared plus 3 squared plus 2 squared plus 1 squared over 2. And when we put it into our calculator, we get an answer of C. Okay, this is a problem that requires a little bit of factoring. It says, for what values of t is the velocity of the particle increasing? So we can say v, using the product rule, is t plus 1 times 3 t minus 3 squared, plus the derivative of the first is just 1, t minus 3 cubed. And before we take a derivative again, I think it's helpful if we do a little factoring. So you get, if you factor out a t minus 3, you get v equals t minus 3 times 3 times t plus 1 plus t plus 3. Oh, sorry, that's a minus 3. So that should be a minus 3. And doing a little bit more work, we get t minus 3 times 3t plus 3, but then we have a minus 3. So you end up with just 4t there. That's v. And if we want to know when the velocity is increasing, we want to know when acceleration is greater than 0. So let's find the second derivative. So acceleration is derivative of the, or we could say first times derivative of the second plus the derivative of the first times the second. Shoot. I'm trying to work too fast. Scrap all that. V equals t plus 1 times 3 t minus 3 squared plus t minus 3 cubed. Okay, now that works. So take out a t minus 3 squared, and what we're left with is 3t plus 3 plus t minus 3, because there's still a t minus 3 left over there. This equals 4t times t minus 3 squared. And our acceleration then is 4 times t minus 3 squared plus 4t times 2t minus 3 to the 1. And we're looking for when acceleration is greater than 0. So if we do a little bit of factoring here, we could factor out a 4 and a t minus 3. So 4 and t minus 3. And what's left is t minus 3 plus 2t. And simplifying this a little bit, we get 4 t minus 3. And here we get 3t minus 3, which simplifies to 4 t minus 3, 3 t minus 1. Lots of algebra here. Now this is just a quadratic with zeros at 1 and 3. And since the leading coefficient is positive, it's going to look something like this. And this, remember, this is our acceleration graph. This is the graph of our acceleration. And so everywhere here and here, our acceleration is positive, which means our velocity is increasing. So as long as t is less than 1 or greater than 3, our answer is correct. Okay, inverse functions. This just brings us back to pre-cal a little bit, but if we say this is y and g is the inverse of f, well then the inverse functions look like this. We just switch the x's and the y's. So you have x equals ln e to the 2y over y minus 1. Well, we know that up top, that's cancels off, so we just have 2y over y minus 1 equals x. So if we solve this for y, we're going to get 2y equals xy minus x, just multiplying. And we could say 2y minus xy equals minus x, moving this over. Factor out a y. And then we get that y equals negative x over 2 minus x. All that work is just so that we can take, and this is g of x, the inverse. And we do all that just so that we can find its derivative. So y prime, it's low, d high, minus high, d low, lots of negative signs, all over low squared. Well, when we put 3 in, we're going to get y prime is 2 minus 3 times minus 1 minus 3 times minus 1 all over 2 minus 3 squared, which equals negative 1 times negative 1. So 1 minus negative 3 times negative 1 is 3 all over 1, which is negative 2. So our answer, negative 2. All right, this problem looks a little bit ugly, but if you just do split it up into two fractions, it becomes really straightforward. So we get e to the x squared over e to the x squared minus 2x over e to the x squared dx. Oh, yeah, just like that. Which is the integral of 1 minus 2x over e to the x squared dx. And if we do a u substitution, let u equal x squared, du equals 2x. Then we can have this being careful here. We've got 1 dx minus the integral, so let's totally split these up, minus the integral of du Oh, so sorry, off to a wrong track here. Better yet. Let's do this. What we need to notice is that this isn't going to be an ln case. It's not going to work out perfectly like that. But if we notice that the numerator is just the derivative, it's not the derivative of the whole denominator, just that piece. Well, what we need to do is a little trick here, is to re-express, let's scrap that for right now, re-express this slightly differently. So we have the integral of 1 dx, so let's just separate these all together, minus the integral of, well, how could we write this differently? We could write that as e to the negative x squared times 2x dx. That negative just flips it over from the denominator to the numerator. Okay, so this is going to be good. So now, again, let's say u equals negative x squared, du equals negative 2x dx. So if I put a negative in here and a negative outside, which is going to make that a positive, we can rewrite this as, well, here we just get x plus the integral of e to the u du, which is just e to the u plus c, where u is this. So we have x plus e to the negative x squared plus c. Okay, so this problem, we have a derivative already given to us, and it's asking a bunch of questions. So we have to decide which are true. So it says the slope of the tangent line to the curve at x equals 2 is -8. Well, that's just, if we plug in 2 into our slope equation, which is the slope equation, let's see if it's -8. So putting in 2, we get 2 minus 1 over 2 minus 4 cubed over 1 plus 2 to the 4th. So 2 to the 4th is 16. So we have 1 times -2 cubed. -2 cubed is -8, all over 17. So that's not true. And it says f is increasing on the interval from 1 to 4. Well, if it's increasing, that means that f prime is greater than 0. And so what we can realize is that if we look at f prime, the denominator doesn't do anything as far as sign goes. The denominator is always going to be greater than 0. So to see when this is greater than 0, we just need to look at when the numerator is greater than 0. And what we can do really easily is notice that this is a 4th degree, because we've got x to the 1 and then x cubed, so it's a 4th degree with zeros at 1 and 4, and the leading coefficient is positive, so it's going to have to look something like that. So in the interval from 1 to 4, the interval from 1 to 4, which is right here, f prime is below the x-axis, so it's not going to be increasing, so it's going to, that can't be true. And lastly, using this graph that we already have, f has a local minimum at x equals 4. That's true because our derivative goes from -0 to positive. So our answer is C. All right, 3 more problems here. All right, this says for f to be continuous and differentiable given this piecewise function. So if it's continuous, it means that at x equals 1, where we switch from one function to the next, at x equals 1, they need to equal each other. So in other words, 1 plus 3b when x equals 1 plus 2x equals 1. So evaluating that at 1 must equal evaluating this function at 1. So mx plus b. So we've got 2 variable equation. We've got b's and m's. Well, if it's differentiable at 1, that means the derivative must exist, which means, if we think about the derivative of this, dx, the derivative of that's going to be 3b plus 4x. And the derivative of this is just m. So at x equals 1, their derivatives must be the same thing. So we're going to get another equation that says 3b plus 4 times 1 must equal m. Well, this is a pretty straightforward system of equation because we already we have m isolated nicely over there. So we have m is 3b plus 4, which we can put in here, simplifying top, adding these, we have 3 plus 3b equals 3b plus 4. That's our m value, plus b. Straight up linear equation. Let's see, we have 3 plus 3b equals 4b plus 4. Moving things over, we have b equals -1. And putting that value in for m, we have m equals 1. So m must be 1 and b must be -1. So our answer is B. All right, 16. The car moving with a bunch of time and speed collections. The closest approximation of the distance traveled. Well, let's use a trapezoid rule. So the change in time is 2. And the trapezoid rule, remember, is 2 times endpoints divided by 2 plus all the interior. Let's see, so can we add this up quickly? So we have 15 plus 76 plus 102 plus 30, which is 2 times. And now notice, doing all this addition, subtraction stuff quickly would behoove you, but you do have a calculator for this section, so you could put it in your calculator. So 91 plus 132, which is 2 times so supposing I did my math right, about 446, so roughly 450. All right, last question here. Let's do a little bit of work first. We could say that f of x equals the integral of from 2 to the x sine of pi t over 4 dt. And this is an accumulation function. Oh, sorry, -5. This is an accumulation function because our function has an integral in it. And it says the value of f of 2 plus f prime of 2. Well, f of 2. These are these sneaky problems that are really easy to do if you can catch it. F of 2 is the integral from 2 to 2 of all that stuff inside dt minus 5. And we know that whenever you integrate with this, from one place to the same place, that whole thing is just 0. So f of 2 is -5. And then we need to find f prime of 2, but let's first find f prime of x. Since our function is just x, f prime of x is just sine of pi x over 4. And then the -5, the derivative of that -5 is 0. And so f prime of 2, we plug 2 in there, x, and we get sine of pi over 2, which you need to know is 1. And so when we add those together, you get -4. Okay, so excluding a couple small mistakes I made, you notice rushing is never good, but there is the solution to these problems. Calculator section, when you can use the calculator, make sure you know how to use it quickly. Otherwise, it ends up being a lot of algebra. So, hope that was helpful. Thank you. Bye.